So today I'm going to discuss natural language processing fundamentals. So natural language processing NLP is the computerized approach to analyzing text that is based on both a set of theories and a set of technologies. And being a very active data of research and development, there is not a single agreed upon definition that would satisfy everyone. But there are some aspects which would be part of any knowledgeable person's definition. The definition I offer is natural language processing is a theoretically motivated range of computational techniques for analyzing and representing naturally occurring text at one or more levels of linguistic analysis for the purpose of achieving human-like language processing for a range of tasks or application. So several elements of this definition can be further detailed later on. Firstly, the imprecise notion of range of computational techniques is necessary because there are multiple methods or techniques from which to choose to accomplish a particular type of language analysis. So, naturally occurring text can be of any language, mode, genre, etc. The text can be oral or written. The only requirement is that they be in a language used by humans to communicate to one another. Also, the text being analyzed should not be specifically constructed for the purpose of the analysis, but rather that the text be gathered from actual uses. The notion of levels of linguistic analysis to be or refers to the fact that there are multiple types of language processing known to be at work when humans produce or comprehend language. It is it is thought that humans normally utilize all of these levels since each level conveys different types of meanings. But various NLP systems utilize different levels or combination of levels of linguistic analysis. And this is seen in differences amongst various NLP applications. So this is also leads to much confusion on the part of non-specialists as to what NLP really is, because a system that uses any subset of these levels of analysis can be said to be an NLP based system. The difference between them, therefore, may actually be whether the system uses weak NLP or strong NLP. So, human like language processing reveals that NLP is considered a discipline within artificial intelligence, AI. And while the full lineage of NLP does depend on a number of other disciplines, since NLP strives for human like performance, and it is appropriate to consider it an AI discipline. So, for a range of tasks or applications, points out that NLP is not usually considered a goal in and of itself, except perhaps for AI researchers. For others, NLP is means for accomplishing a particular task. Therefore, you have information retrieval IR systems that utilize NLP, as well as medicine translation MT, question answers, etc. Now, the goal. The goal of NLP is to accomplish human like language processing. The choice of the word processing is very deliberate and should not be replaced with understanding. For although the field of NLP was originally referred to as natural language understanding, NLU, in the early days of AI, it is well agreed today that while the goal of NLP is true NLU, that goal has not yet been accomplished. So a full natural language understanding NLU system would be able to paraphrase and input text, Secondly, translate the text into another language. Number three, answer questions about the contents of the text. And the last one, draw inferences from the text. While NLP has made serious inroads into accomplishing goals, um, uh, all these goals like paraphrase and input text, translate the text into another language, and answer questions about the contents of the text. The fact that NLP systems cannot, uh, of themselves, draw inferences from texts, so NLU still remains, natural language understanding still remains the goal of natural language processing, NLP. So there are more practical rules for NLP, many related to the particular application for which it is being utilized. For example, an NLP based IR system has the goal of providing more precise, complete information in response to a user's real information need. So the goal of the NLP system here is to represent the true meaning and intent of the user's query, which can be expressed as naturally in everyday language as if they were speaking to a reference librarian. Also, the contents of the documents that are being searched will be represented at all their levels of meaning so that a true match between need and response can be found, no matter how either are expressed in their surface form. Then comes origins. So, as most modern disciplines, the lineage of NLP is indeed mixed and still today has strong emphasis by different groups whose backgrounds are more influenced by one or more or one or another of the disciplines. So, key among the contributors to the discipline and practice of NLP are linguistics, focuses on formal structural models of language and the discovery of language universals. In fact, the field of NLP was originally referred to as computational linguistics. Okay, so computer science is concerned with developing internal representation of data and efficient processing of these structures. And cognitive psychology also looks at language usage as a window into human cognitive processes and has the goal of modeling the use of language in psychologically plausible way. Then comes divisions. So while the entire field is referred to as natural language processing, there are in fact two distinct focuses: language processing and language generation. Okay, I repeat, language processing and language generation. The first of these refers to the analysis of language for the purpose of producing a meaningful representation, while the latter refers to the production of language from a representation. So, the task of natural language processing is equivalent to the role of reader or listener, while the task of natural language generation is that of the writer or speaker. While much of the theory and technology are shared by these two divisions, so natural language generation also requires a planning capability. That is, the generation system requires a plan or model of the goal of the interaction in order to decide what the system should generate at each point in an interaction. So we will focus on the task of natural language analysis as this is most relevant to library and information science. Another distinction is traditionally made between language understanding and speech understanding. So, speech understanding starts with and speech generation ends with oral language and therefore rely on the traditional fields of acoustics and phonology. So, speech understanding focuses on how the sounds of language as picked up by the system in the form of acoustical waves are transcribed into recognizable morphemes and words. So once in this form, the same levels of processing which are utilized on written text are utilized. So all of these levels, including the phonology level, will be I will be covered later on. However, the emphasis throughout will be on language in the written form. Okay, so this is brief history of natural language processing. So natural language processing (NLP) has a rich history dating back in the late 1940s. One of the earliest endeavors in this field was machine translation, initiated by researchers like Weaver and Booth in 1946, drawing upon wartime code breaking expertise. So Weaver's influential 1949 memorandum on MT, machine translation, sparked interest and inspired various projects. However, early MT systems were simplistic, relying mainly on dictionary lookup and word order rules, resulting in poor translations due to the inherent ambiguity of natural language. In 1957, Chomsky's publication of Syntactic Structures introduced generative grammar, providing insights into how linguistic theory could be could aid MT. During this period, the NLP landscape saw the emergence of other applications such as speaker recognition, leading to a divide between camps favoring theoretical linguistic and statistical methods. Over enthusiasm in the 1950s led to unrealistic expectations of fully automated high quality translation systems, promoting the ALP report in 1966, which halted funding for MT and NLP projects in the United States. Despite these setbacks, theoretical advancements continue with efforts to develop computationally tractable solutions for meaning representations. So the late 1960s and early 1970s witnessed the development of various linguistic theories such as transformational generative grammars by Chomsky, case grammar by Fillmore, semantic networks by Quillen, and conceptual dependency theory by Chang. So prototype systems like ELIZA and Shudliu demonstrated early attempts at natural language understanding and interaction. Next slide. To be continued, the history. The late 1970s and early 1980s saw a shift towards the semantic issues and discourse analysis. So researchers delved into discourse phenomena and communicative goals, leading to the development of theories such as rhetorical structure theory. So this period also saw advancements in natural language generation with systems like text and mumble producing coherent responses. By the late 1980s, there was a resurgence of interest in non-symbolic approaches to NLP, driven by computational advancements and a recognition of the limitations of isolated solutions. So the last decade of the millennium witnessed rapid growth in the field, fueled by increased availability of electronic text, faster computers, and the rise of the internet. So statistical approaches gained prominence, addressing problems such as part of speech identification and word sense disambiguation. Today, NLP research continues to evolve with the development of next generation systems capable of handling the variability and ambiguity of language more effectively. So the field remains vibrant with ongoing efforts to advance NLP techniques and applications. Okay, then the levels of natural language processing. The most explanatory method for representing what actually happens within a natural language processing system is by means of the levels of language approach. So this is also referred to as synchronic model of language, and it is distinguished from the earlier sequential model, which hypothesizes that the levels of human language processing follow one another in a strictly sequential manner. So, psycholinguistic research suggests that language processing is much more dynamic as the levels can interact in variety of orders. So, introspections reveals that we frequently use information we gain from what is typically thought of as a higher level of processing to assist in a lower level of analysis. For example, the pragmatic knowledge that the document you are reading is about biology will be used when a particular word that has several possible senses or meanings is encountered, and that and the word will be interpreted as having the biology sense of necessity. The following the description of levels will be presented sequentially. So the key point here is that meaning is conveyed by each and every level of language, and that since humans have been shown to use all levels of language to gain understanding, the more capable an NLP system is, and the more levels of language it will utilize. So the first one is phonology. Okay, now this level deals with the interpretation of speech sounds within and across words. So there are in fact three types of rules used in phonological analysis. Okay, the first, phonetic rules for sounds within words. Second, phonemic rules for variations of pronunciation when words are spoken together. And the third one is prosodic rules for fluctuation in stress and intonation across a sentence. So, in the NLP system that accepts spoken input, the sound waves are analyzed and encoded into a digitized signal for interpretation by various rules or by comparison to the particular language model being utilized. Then the second level is morphology. So this level deals with the componential nature of words, which are composed of morphemes. So the smallest morphemes means the smallest units of meaning. For example, the word pre-registration, okay, can be morphologically analyzed into three separate morphemes: the prefix pre, the root registra, and the suffix shun, that means tion. So, since the meaning of each morpheme remains the same across words, humans can break down an unknown word into its constituent morphemes in order to understand its meaning. Similarly, NLP system can recognize the meaning conveyed by each morpheme in order to gain and represent meaning. For example, adding the suffix ed to a verb conveys that the action of the verb took place in the past. This you all know. And this is a key piece of meaning, and in fact, is frequently only evidenced in a text by the use of the ed morpheme. Then the next level is lexical. At this level, humans as well as NLP systems interpret the meaning of individual words. So, several types of processing contribute to word level understanding. The first of these being assignment of a single part of speech tagged to each word. So, in this processing, words that can function as more than one part of speech are assigned the most probable part of speech tag based on the context in which they occur. Additionally, at the lexical level, those words that have only one possible sense or meaning can be replaced by a semantic representation of that meaning. So the nature of the representation varies according to the semantic theory utilized in the NLP system. The following, what you can say, the actually the meaning of the word launch is in the form of logical predicates. As can be observed, a single lexical unit is decomposed into its more basic properties. Given that there is a set of semantic primitives used across all words. So these simplified lexical representations make it possible to unify meaning across words and to produce complex interpretations much the same as humans do. So the lexical level may require a lexicon, and the particular approach taken by an NLP system will determine whether a lexicon will be utilized, as well as the nature and extent of information that is encoded in the lexicon. So lexicons may be quite simple with only the words and their parts of speech, or maybe increasingly complex and contain information on the semantic class of the word, what argument it takes, and the semantic limitations on these arguments, then definitions of the sense in the semantic representation utilized in a particular system, and even the semantic field in which each sense of polysemous word is used. Then comes syntactic. So this level focuses on analyzing the words in a sentence so as to uncover the grammatical structure of the sentence. So this requires both a grammar and a parser. The output of this level of processing is possibly delinearized representation of the sentence that reveals the structural dependency relationships between the words. So there are various grammars that can be utilized and which will in turn impact the choice of a parser. Not all NLP applications require a full parse of sentences. Therefore, the remaining challenge in parsing of prepositional phrase attachment and conjunction scoping no longer stymie those applications for which phrasal and clausal dependencies are sufficient. So, syntax conveys meaning in most languages because order and dependency contribute to meaning. For example, the two sentences, the dog chased the cat and the cat chased the dog, differ only in terms of syntax, yet convey quite different meanings. Okay, so this is about syntactic. Then the next is semantic. So this is the level at which most people think meaning is determined. However, as we can see in the previous defining of the levels, it is all the levels that contribute to meaning. So semantic processing determines the possible meanings of a sentence by focusing on the interactions among word level meanings in a sentence. So this level of processing can include the semantic disambiguation of words with multiple senses in an analogous way to how syntactic disambiguation of words that can function as multiple parts of speech is accomplished at the syntactic level. So semantic disambiguation permits one and only one sense of polysemous words to be selected and included in the semantic representation of the sentence. For example, amongst other meanings, file. File as a noun can mean either a folder or storing papers, or a tool to shape one's fingernails, or line of individuals in a queue. If information from the rest of the sentence were required for the disambiguation, the semantic, not the lexical level, would do the disambiguation. So a wide range of methods can be implemented to accomplish the disambiguation, some which require information as to the frequency with which each sense occurs in a particular corpus of interest or in general uses. So some which require consideration of the local context, and others which utilize pragmatic knowledge of the domain of the document. Then comes discourse. While syntax and semantics works with sentence length units, the discourse level of NLP works with units of text longer than a sentence. Okay, that is, it does not interpret multi-sentences or multi-sentence text as just concatenated sentences, each of which can be interpreted singly. Rather, discourse focuses on properties of the text as a whole that convey meaning by making connections between component sentences. So several types of discourse processing can occur at this level. Two of the most common being anaphora resolution and discourse text structure recognition. Now, anaphora resolution is the replacing of words such as pronouns, which are semantically vacant, with the appropriate entity to which they refer. Discourse text structure recognition determines the functions of sentences in the text, which in turn adds to the meaningful representation of the text. For example, newspaper articles can be deconstructed into discourse components such as lead, main story, previous events, evaluation, attributed quotes, and expectations. Then comes pragmatic. So this level is concerned with the purposeful use of language in situations and utilizes context over and above the context of the text for understanding. So the goal is to explain how extra meaning is read into texts without actually being encoded in them. So this requires much world knowledge, including the understanding of intentions, plans, and goals. So some NLP applications may utilize knowledge bases and inferencing modules. For example, the two sentence uh, require the two sentences which I'm going to tell you require resolution and the anaphoric term they, but this resolution requires pragmatic or world knowledge. The first sentence is the city councillors refuse the demonstrators a permit because they feared violence. This is first sentence. And the second, the city councillors refused to demonstrate a permit because they advocated revolution. So these two sentences require resolution of the anaphoric term they, but this resolution requires pragmatic or world knowledge. Okay, the summary of levels. So current NLP systems tend to implement modules to accomplish mainly the lower levels of processing. So this is for several reasons. First, the application may not require interpretation at higher levels. Secondly, the lower levels have been more thoroughly researched and implemented. Thirdly, the lower levels deal with smaller units of analysis, example, morphemes, words, and sentences, which are rule govern uh, versus the higher levels of language processing which deal with text and word knowledge and which are only regularity governed, as will be seen in the following section on approaches. The statistical approaches have to date been validated on the lower levels of analysis, while the symbolic approaches have dealt with all levels, although there are still few working systems which incorporate the higher levels. Then comes approaches to natural language processing. Now, natural language processing approaches fall roughly into four categories: symbolic, statistical, connectionist, and the fourth one I forgot, and hybrid. Okay, so symbolic and statistical approaches have coexisted since the early days of this field. So connectionist NLP work first appeared in 1960s. For a long time, then symbolic approaches dominated the field, and in the 1980s, statistical approaches regained popularity as a result of the availability of critical computational resources and the need to deal with broad real world context. So connectionist approaches also recovered from earlier criticism by demonstrating the utility of neural networks in NLP. So this particular section examines each of these approaches in terms of their foundations, typical techniques, differences in processing and system aspects, and their robustness, flexibility, and suitability for various tasks. So first we'll see a symbolic approach. Now, a symbolic approaches perform deep analysis of linguistic phenomena and are based on explicit representation of facts about language through well understood knowledge representation schemes and associated algorithms. In fact, the description of the levels of language analysis in the uh, um, in the preceding point is given from a symbolic perspective, and the primary source of evidence in symbolic systems comes from human developed rules and lexicons, as we discussed earlier. So a good example of symbolic approaches is seen in logic or rule-based systems. Okay, so in logic-based systems, the symbolic structure is usually in the form of logic propositions. Manipulations of such structures are defined by inference procedures that are generally truth-preserving, and rule-based systems usually consist of a set of rules, an inference engine, and a workspace or working memory. So knowledge is represented as facts or rules in the rule base. The inference engine repeatedly selects a rule whose condition is satisfied and executes the rule. Another example of symbolic approaches is semantic networks. So first proposed by Quillen to model associative memory in psychology. So semantic networks represent knowledge through a set of nodes that represent objects or concepts, and the labeled links that represent relations between nodes. So the pattern of connectivity reflects semantic organization, that is highly associated concepts and are directly linked, whereas moderately or weakly related concepts are linked through intervening concepts. So semantic networks are widely used to represent structured knowledge and have the most connectionist flavor of the symbolic models. So symbolic approaches have been used for a few decades in a variety of research areas and applications such as information extraction, text categorization, ambiguity resolution, and lexical acquisition. So typical techniques include explanation-based learning, rule-based learning, inductive logic programming, decision trees, conceptual clustering, and k-nearest neighbor algorithms. So these are some typical techniques. Then the second approach is a statistical approach. Statistical approaches employ various mathematical techniques and often use large text corpora to develop approximate generalized models of linguistic phenomena based on actual examples of these what you can say phenomena provided by the text corpora without adding significant linguistic or world knowledge. So in contrast to symbolic approaches, statistical approaches use observable data as the primary source of evidence. A frequently used statistical model is the hidden Markov model, which we call HMM, inherited from the speech community. So, hidden Markov model is a finite state automation that has a set of states with probabilities attached to transitions between states. So although outputs are visible, states themselves are not directly observable, thus hidden from external observations. So each state produces one of the observable outputs with a certain probability. So statistical approaches have typically been used in tasks such as speech recognition, lexical acquisition, parsing, parts of speech tagging, collocations, statistical machine translation, statistical grammar learning, and so on. Then the next approach is a connectionist approach. So similar to the statistical approaches, connectionist approaches also develop generalized models from examples of linguistic phenomena. What separates connectionalism from other statistical method is that connectionist model or models combine statistical learning with various theories of representation. Thus, the connectionist representations allow transformation, inference, and manipulation of logic formulae. In addition, in connectionist system, linguistic models are harder to observe due to the fact that connectionist architectures are less constrained than statistical ones. So generally speaking, a connectionist model is a network of interconnected simple processing units with knowledge stored in the weights of the connections between units. So local interactions among units can result in dynamic local behavior, which in turn leads to computation. So some connectionist models are called localist models, assuming that each unit represents a particular concept. For example, one unit might represent the concept mammal, while another unit might represent the concept veil. So relations between concepts are encoded by the weights of connection between those concepts. So knowledge in such models is spread across the network, and the connectivity between units reflects their structural relationships. So localist models are quite similar to semantic networks, but the links between units are not usually labeled as they are in semantic nets. So they perform well at tasks such as word sense disambiguation, language generation, and limited inference. Other connectionist models are called distributed model. Unlike that, in localist models, a concept is distributed model. A concept in distributed models is represented as a function of simultaneous activation of multiple units. So an individual unit only participates in a concept representation. So these models are well suited for natural language processing tasks such as syntactic parsing, limited domains translation task, and associative retrieval. Okay, so this is a comparison among approaches. Okay, so from the previous information which I shared, we have seen that similarities and differences exist between approaches in terms of their assumptions, philosophical foundations, and source of evidence. So, in addition to that, the similarities and differences can also be reflected in the processes each approach follows, as well as in system aspects, robustness, flexibility, and suitable tasks. So the first is process. So research using these different approaches follows a general set of steps, namely data collection, data analysis or model building, rule or data construction, and application of sorry, rules or data in system. So the data collection stage is critical to all three approaches, although statistical and connectionist approaches typically require much more data than symbolic approaches. So in the data analysis or model building stage, symbolic approaches rely on human analysis of the data in order to form a theory, while statistical approaches manually define a statistical model that is an approximate generalization of the collected data. Then connectionist approaches build a connectionist model from the data, and in the rule or data construction stage, manual efforts are typical for symbolic approaches, and the theory formed in the previous step may evolve when new cases are encountered. So, in contrast, statistical and connectionist approaches use the statistical or connectionist model as guidance and build rules or data items automatically, usually in relatively large quantity. After building rules or data items, all approaches then automatically apply them to specific tasks in the system. For example, connectionist approaches may apply the rules to train the weights of links between units. Then system aspects. By system aspects, we mean source of data, theory or model formed from data analysis rules and basis for evaluation. Then data. As mentioned earlier, symbolic approaches use human introspective data, which are usually not directly observable. So statistical and connectionist approaches are built on the basis of machine observable facets of data, usually from text corpora. Then the theory or model based on data analysis. So as the outcome of data analysis, a theory is formed for symbolic approaches, whereas a parametric model is formed for statistical approaches, and connectionist model is formed for connectionist approaches. Then rules. For symbolic approaches, the rules construction stage usually results in rules with detailed criteria of rule application. For statistical approaches, the criteria of rule applications are usually at the surface level or underspecified. And for connectionist approaches, individual rules typically cannot be recognized. Then, basis for evaluation. So, evaluation of symbolic systems is typically based on intuitive judgments of unaffiliated subjects and may use system internal measures of growth, such as the number of new rules. So, in contrast, the basis for evaluation of statistical and connectionist systems are usually in the form of scores computed from some evaluation function. However, if all approaches are utilized for the same task, then the results of the task can be evaluated both quantitatively and qualitatively and compared. Then robustness. You know, um, symbolic systems may be fragile when presented with unusual or noisy input. To deal with anomalies, they can anticipate them by making the grammar more general to accommodate them. Compared to symbolic systems, statistical systems may be more robust in the face of unexpected input, provided that training data is sufficient, which may be difficult to be assured of. Then connection systems may also be robust and fault tolerant because knowledge in such system is stored across the network. And when presented with noisy input, they degrade gradually. Then comes flexibility. So since symbolic models are built by human analysis of well formulated examples, symbolic systems may lack the flexibility to adapt dynamically to experience. So, in contrast, statistical systems allow broad coverage and may be better able to deal with unrestricted text for more effective handling of the text of handling of the task at hand. So, connectionist system exhibit flexibility by dynamically acquiring appropriate behavior based on the given input. For example, the weights of connectionist network can be adapted in real time to improve performance. However, such system may have difficulty with the representation of structures needed to handle complex conceptual relationships, thus limiting their abilities to handle high-level NLP. Then suitable tasks. So symbolic approaches seem to be suited for phenomena that exhibit identifiable linguistic behavior. So they can be used to model phenomena at all the various linguistic levels described earlier. So statistical approaches have proven to be effective in modeling language phenomena based on frequent use of language as reflected in text corpora. So linguistic phenomena that are not well understood or do not exhibit clear regularity are candidates for statistical approaches. Similar to statistical approaches, connectionist approaches can also deal with linguistic phenomena that are not well understood. So they are useful for low-level NLP tasks that are usually subtasks in a larger problem. So to summarize, symbolic, statistical, and connectionist approaches have exhibited different characteristics. Thus, some problems may be better tackled with one approach while other problems by another. So in some cases, for some specific tasks, one approach may prove adequate, while in other cases, the tasks can get so complex that it might not be possible to choose a single best approach. So in addition, as one of the great researchers, Lavins and uh, um, Grasnik pointed out, there is no such things as purely statistical method. So every use of statistics is based upon a symbolic model, and statistics alone is not adequate for NLP. So towards this end, statistical approaches are not at odds with symbolic approaches. In fact, they are rather complementary. And as a result, researchers have begun developing hybrid techniques that utilize the strengths of each approach in an attempt to address NLP problems more effectively and in more flexible manner. Okay, then here comes natural language processing applications. So natural language processing provides both theory and implementations for a range of applications. In fact, any application that utilizes text is candidate for NLP. So the most frequent applications utilizing NLP include first information retrieval, okay, which we call IR. So given the significant presence of text in this application, it is surprising that so few implementations utilize NLP. Recently, statistical approaches for accomplishing NLP have been more utilization, but few systems other than those have developed significant systems based on NLP. Then the second is information extraction, which we call IE, a more recent application area. IE focuses on the recognition tagging and extraction into structured representation, certain key elements of information, example, persons, companies, locations, organizations, from large collection of text. So these extractions can then be utilized for a range of applications, including question answering, visualization, and data mining. Then the next application is question answering. So in contrast to information retrieval, which provides a list of potentially relevant documents in response to user's query, question answering provides the user with either just the text of the answer itself or answer providing passages. Then summarization. So the higher levels of NLP, particularly the discourse level, can empower an implementation that reduces a large text into a shorter, yet richly constituted, abbreviated narrative representation of the original document. Then machine translation. Perhaps the oldest of all NLP applications, various levels of NLP have been utilized in machine translation systems, ranging from the word-based approach to applications that include higher levels of analysis. Then dialogue systems, perhaps the omnipresent application of the future in the systems envisioned by large providers of end user applications. So dialogue systems, which usually focus on narrowly defined applications, for example, your refrigerator or home sound system, currently utilize the phonetic and lexical levels of language. So it is believed that utilization of all the levels of language processing explained uh, just now offer the potential for truly habitable dialogue systems. So these are some applications of NLP. The next slide, please. Finally, conclusion. Okay. So while NLP is a relatively recent area of research and application as compared to other information technology approaches, there have been sufficient successes to date that suggests that NLP-based information access technologies will continue to be a major area of research and acknowledgement in information systems now and far into the future.